SeaOne Maritime Corp provides an economic alternative method of marine transportation of natural gas in a liquid pipeline system aboard a CGL carrier. This video will be in 3 parts. First, a discussion of the gas phase and technology that is published. Second, an initial validation run on the phase envelope under operational conditions that will show the making of CGL. And finally, a larger scale test that will show the making of CGL, the displacement of CGL in and out of the pipeline containment system that demonstrates the commercial aspects of the LNG light system. Let's discuss the available public data on the process. This is a typical phase envelope for lean natural gas used for the tests at 1400 psig and minus 40 degrees Fahrenheit. Adding 18% propane to the natural gas stream creates a CGL mixture. The dot shows where the optimal operating conditions will be for the maximum packing or volumetric ratio for the CGL mixture. At this point, the CGL is a clear, stable liquid. The commercialization of SeaOne's compressed gas liquid, or CGL, gas transportation system requires that SeaOne prove the actual process of making, loading, and unloading the CGL in and out of the pipe containment system aboard a CGL carrier. The existence of compressed gas liquid has been known since the early research by SeaOne. The gas sciences were further reviewed and validated by laboratory testing. Our first demonstrated test to show the formation of CGL was a small laboratory test. In that test, we followed the following path on the phase envelope. For the lean natural gas mixture used, the bubble point occurred at 1050 psi. You can see the liquid gas forming. As the pressure was raised to 1200 psi, it was much more in the liquid phase. And by the time it eventually reached the operating conditions of 1400 psi and minus 40 degrees Fahrenheit, it was a clear, stable liquid. This is not the commercial sequence used in the LNG light process, where the already formed CGL will be loaded into the pipeline containment system as a liquid aboard the carrier at 1400 psi and minus 40 degrees Fahrenheit. For that reason, this demonstrated capabilities presentation has been prepared to show test equipment, systems, and the results of that test, which was conducted over a period of 6 months. The test was designed to confirm and prove 3 processes. 1. The making of compressed gas liquid or CGL on a large scale. 2. The loading. And 3. The unloading of CGL into and from a pipe system. Federal regulations mandate that a proof of concept be completed before entry into the marketplace. In order to conduct the proof of concept test, the SeaOne team constructed a test facility on a site located in Texas City, Texas. The CGL is created on the production loading barge located at the field and then loaded aboard the CGL carrier. The CGL is loaded into the floating pipeline containment system by displacing a methanol water solution in the empty containment system. Once the CGL cargo is loaded, the carrier goes to market, where the CGL is unloaded from the containment system to the offloading barge by, again, using the same methanol water displacement system. A test facility was built that shows how the 3 important features were proved. A scale model of the containment system was built. As with all tests of this nature, safety is a #1 priority. For that reason, a protective barrier was assembled to secure the model and protect the personnel. For the purposes of this test, a series of 4 interconnected pipes and holding tanks were built to simulate the containment system. As part of the test system, a mixing chamber was constructed where the natural gas and the solvent, which is 15 to 18% propane, were combined and placed in series with the holding tanks and pipes. A window made of 4-inch safety glass was installed at the ends of each pipe to allow the viewing of the process as it occurred. A cooling system was constructed to lower the temperature of the model to minus 40 degrees. For compression requirements, the team selected medium-pressure nitrogen gas for this purpose. For a natural gas source, pipeline-grade natural gas was used. For the solvent, commercial-grade propane was used. For the displacement medium, the SeaOne team used a methanol water mix. To inert the containment system, nitrogen gas was used. For gas and CGL quality assurance, we continuously monitored the process using a gas chromatograph. The test system was assembled and installed in an enclosed box. Cameras were installed at one end of each pipe to monitor the loading of the methanol water into each pipe. The process was manually controlled and continuously monitored by a computer system, while cameras were used for visual observations. Team members were able to continuously monitor the test and capture the images using a digital video recording system that recorded the camera images in real time throughout the test. In the real-world application, SeaOne Maritime CGL carriers are used to transport the natural gas in a liquid form from the production site to market. Changing the state of natural gas to CGL allows large amounts of the gas to be transported using less energy, which is a tremendous economic advantage for producers. We are now going to demonstrate the making of CGL. To demonstrate the formation of the CGL in the test model, we are using the actual video captured during the CGL validation test, sped up several times in the mixing chamber. In this video, you see the natural gas and propane mixture flowing into the mixing chamber, which is at 1400 psig and minus 40 degrees Fahrenheit. We are now going to demonstrate the loading of the CGL into the pipe system. Here is the view of the first pipe in the sequence. The pipe system is preloaded with methanol water. During the loading process, the CGL is in contact with the methanol water under pressure and temperature. As the CGL enters the pipe from the top, it displaces the methanol water out of the bottom of the pipe. This arrow indicates where the CGL and the methanol water meet, but they do not mix due to their different densities. As the first pipe completes filling, the second pipe is filled and monitored. The CGL displaces the methanol water out as it moves through the pipe system. The process continues until all pipes have been filled with CGL. Using this methanol water displacement medium eliminates sloshing when the carrier is moving. Aboard the CGL carrier, the CGL is stored in the pipeline containment system while the carrier makes its journey to the offloading destination. Upon the arrival of the CGL carrier at the point of unloading, the CGL cargo is unloaded to the offloading barge. We are now going to demonstrate the unloading of the CGL from the pipe system. In this process, the CGL is displaced out of the pipe system from the bottom upwards using methanol water. The team members are able to monitor and control the entire process using a computer-controlled monitoring system. This test has been completed, and we have shown that the process of creating, loading, storing, and unloading the CGL is viable.